Welcome to graphing trig functions. So we made it. And so now we're in the graphing portion of the trig functions lesson. I have some of this recorded previous years, but it's not full lessons. So I also changed this up a little bit. I may try to incorporate some of those. We'll see. So I don't have to record the entire thing in 1 or 2 days. All right, so a periodic function is a function whose values repeat at regular intervals. Sine and cosine are examples of periodic functions. The part of the graph from any point to the point where the graph starts repeating itself is called a cycle. So we have not seen any periodic functions yet. None of our different functions that we've graphed are periodic functions. None of them are ones that repeat. So this is all new to us. And I have this all in your notes. So the period is the difference between the horizontal coordinates corresponding to one cycle. In other words, how long does it take before the graph starts to repeat itself again? And we'll learn how to calculate that out. So here we have two examples of graphs. One is periodic and one is not periodic. Right? So notice that the one graph on the left there keeps repeating itself. Right? It goes back and forth between the same values. So a period is the distance it takes before the graph starts to repeat itself. So any of those green lines there show you a period, right? That's how long it takes before it repeats itself, right? So it kind of just depends where you're starting to look, right? So from here to here is a period, right? Because I have the same pattern over again. But if I'm looking here, my graph repeats itself here. Either way, it's the same distance. Right? I guess I should have used different colors. Right? So this is right here. That's also a period. Right? The other graph, that's not periodic. It's not repeating itself. It's zigzaggy, but it's not the same zigs or the same zags. So not periodic, just to show you the difference. So let's look at some things about periodicity. So periodicity is common in nature. Day-night cycles, rotation of the Earth, right? Every 12 hours we kind of repeat our, when the light's out, when the sun is out, right? As we rotate around the sun. Pendulums and other swinging movements, right? They keep repeating the same pattern over and over again. Ocean waves, birth, marriage, death cycle, other things, right? Musical rhythm, linguistic rhythm, eating, sleeping, dribbling, juggling, calendars, fashion cycles, economic, political, lots of things, right? Go in cycles. Over here we have a normal sinus rhythm. That's your heartbeat. That's also periodic. And you hope it's periodic. And if it's not, there's a problem, right? So it just repeats the same rhythm over and over again. Right? So lots of things follow that. A little vocabulary for you. It's in your notes. Right? So a unit circle is a circle whose radius is 1 and whose center is the origin. Right? Again, so here notice where theta is, the angle measure. That would be in standard position. Right? So this is the initial and this is the terminal side. So we're going to be using those angles that we learned about in the trig ratios portion to be able to graph, because that's going to play a part of this. Right? So since our radius there, that is always 1. I show you a couple places that are easy to figure out. They are when we're on a horizontal or vertical line. So our radius would go from 1, 0 to 0, 1 to -1, 0 to 0, -1. Lots of other values in between, but they're not quite as easy to calculate out, although they're not that complicated either. And there we are at the origin. Just the graph of a circle, right? We could find other points on the graph of a circle. But we're going to focus on those because those are easy to work with. We'll talk more about the unit circle. I'm just going to introduce some things to you. That's not a good thing to see. All right, so I'm going to try to end at the end of this. I'm going to talk fast. All right, so here we're going to just use special right triangles to find some measures here. So there's some things we've learned before. All right, so here I have some important ones. All right, I have the 30, 60, 90, or you can think of it as pi 6, pi thirds, 90. So my reference angle there is 30 degrees, or pi 6. Opposite would be 1. Adjacent would be square root of 3, and the radius is 2. For that angle, my sine ratio is 1. Sine 30 would be 1/2. That particular point would be either 30 1/2 or pi 6 1/2. We're going to keep it to radians though, right? Because the radians is going to be the measure we work with. For cosine, there you are. Right? Cosine's adjacent over hypotenuse, so square root of 3 over 2. So a point on the cosine graph would be pi 6 square root of 3 over 2. Tangent is opposite over adjacent, right? So that would be 1 over square root of 3. When we rationalize it, it was square root of 3 over 3. So a point on the tangent graph is pi 6 and pi thirds over 3. And you'll see how these come into play a little later on. Right? We'll actually only be graphing sine and cosine, but in this little introduction I included the other graphs as well, including tangent, which we're not graphing, and cosecant, secant, and cotangent. So cosecant is hypotenuse over opposite, so that would be 2 over 1, or just 2. So pi 6 2 would be a point on the cosecant graph. Secant is hypotenuse over adjacent. That would be 2 over the square root of 3, and when we rationalize it, it's 2 square roots of 3 over 3. So a graph on the cosecant graph would be pi 6, 2 square roots of 3 over 3. And cotangent is adjacent over opposite. Right? So the adjacent is square root of 3 and the opposite is 1, so that would be square root of 3. So pi 6 square root of 3 is a point on the cotangent graph. So these are just coming from our special right triangles. So whenever we have a sine, cosine, tangent, etc. of a 30-degree or a pi 6 radian angle, we can replace that measure with the equivalent value. So for instance, if we had, let's go to sine and cosine, so that's the ones we're going to be working with. So if we had sine pi 6 or sine 30, we could replace that with 1/2. That's its value. Right? And let's go on to another type of angle, which is the 60-degree angle. Same right triangle, it's just now it's the short leg that's the adjacent side, and the 60-degree angle, the long leg, opposite the 60-degree angle, the long leg, that's the opposite side. So sine 60 would be opposite over hypotenuse, so square root of 3 over 2. And so, the point pi thirds, square root of 3 2 is a point on the sine graph. Cosine is adjacent over hypotenuse, so that would be 1 over 2, 1/2. So a point on the cosine graph is pi thirds 1/2. Tangent is opposite over adjacent, so that's going to be square root of 3 over 1 or just square root of 3. So pi thirds square root of 3 is a point on the tangent graph. Come on. Oh, there they are, change right. Cosecant is hypotenuse over opposite. Right, so that's going to be 2 square roots of 3 over 3, right, because we have to rationalize it. So pi thirds 2 square roots of 3 over 3 is a point on cosecant. Secant is hypotenuse over adjacent, so that's just going to be 2. So pi thirds 2 is a point on the secant graph. And cotangent is adjacent over opposite, 1 over square root of 3, or when we rationalize it, square root of 3 over 3. So pi thirds square root of 3 over 3 is a point on the cotangent graph. Whenever we have sine, cosine, tangent, etc. of a 60-degree or a pi thirds radian angle, we can replace that measure with the equivalent value, right? And we'll follow the equal sign. That's its equivalent value. It was the y value for all of those when I wrote it as a point. And last one here, we have sine 45. It's going to be 1 over square root of 2, or square root of 2 over 2, square root of 2 over 2. So pi fourths square root of 2 over 2 is a point on the sine graph. It's also a point on the cosine graph, right? Because the opposite and adjacent sides are exactly the same. Tangent is opposite over adjacent, so it's going to be 1 over 1 or just 1. So pi fourths 1 is a point on the tangent graph. That's an easy point to graph. Cosecant is hypotenuse over opposite, so that's going to be square root of 2 over 1 or just square root of 2. Pi fourths square root of 2 is a point on the cosecant graph. It's also a point on the secant graph, right? Because it got the same opposite and adjacent side. And square root of 4, 1 is a point on the cotangent graph. So whenever we have the sine, cosine, tangent, etc. of a 45-degree or a pi force radian angle, we can replace that measure with the equivalent value. All right, so in the next lesson, after I clear off some space, we're going to look at graphing sine and cosine. Bye for now.